Chapter 4, Section 6.3, Part 2, Video. In these examples, we'll be looking at finding the x-intercept, the y-intercept, and the vertex. So we will graph it to find the x-intercept and the vertex, and then we will do a little bit of math to prove to you a basic understanding about a quadratic in standard form. So the first thing that we do is we graph this. So 4x squared plus 25x plus 6. So y equals 4x squared. Let's just go clear. 4x squared. What was it? 25x plus 6 plus 25x plus 6. Okay, now we hit graph. Okay, so zoom 6, which is what my particular graph is set up on, shows you the quadratic, but it doesn't show you the minimum. Okay, so if I go zoom 0, then it'll keep my negative 10 to 10 on the x-axis and show my little dip right there. Now, we need to find the x-intercepts, the y-intercept, and the vertex. Note that these little help things say put them as points. Don't leave them as just a standard value. Okay, put it as an ordered pair. So let's go find the x-intercepts real quick. So doing this, we'll have second trace. We want to find the zeros. The x-intercepts are the zeros. Okay. So let's start, and that the zero or the solutions or the x-intercepts is where it crosses the x-axis. So we want to be above on this one for left bound, and then we'll go below it to create a right bound, and then I'll look between these 2 points to find where the output is 0. So the x is negative 6. So let's go back over here. So it'll be, all right, and let's go grab the other one. Well, again, we'll go second trace 2 for zeros. We're going to move this over till we come, and we'll go create a left bound. Okay, right there, enter. You go on this above it and create enter. Now we've got it where it crosses the x-axis in between my left and right bound, which is what I want, and then hit enter again. So it'd be negative 0.250. So negative 0.25 comma 0. So those are my x-intercepts, okay? Now, let's go find the vertex, and then we'll come back and talk about the y-intercept here in a second. So the vertex is down here. It's the minimum. So second trace, number 3, and we're going to create a left bound and a right bound. Okay, we just need to be just on, not down in the valley, but we need to be up on a side. Now, where up on that side, it really doesn't matter, as long as you're not down in the valley, okay, the lowest point. So I've got my left bound and right bound. They are a little lopsided, as you can see. I've got a little bit more up on my left, but that's okay. I don't want to be down here in the swag of it, okay, in the little minimum part. Enter again, and my minimum is negative 3.125, comma, negative 33.0625. Again, points, right? Now, let's go answer that probably the easiest one there is, and it's the y-intercept, right? If we go look at here, we'd have to go, oh my, where's my y-intercept at? Where's it crossing? Well, we don't have to guess. We know it. The y-intercept is when x equals 0, and I'm about to prove to you. So if we take and plug in 0 for every x in the equation, you will find that the y-intercept is 6. That's 0, 6. If it's in standard form, which this is in standard form, your c, which is better known as a constant, okay, will always be your y-intercept. Okay. Now, granted, my calculator doesn't look like that's at 6, right? But I want you to see something. My window limits for my y are negative 33 and 656. It's going to make a 6 appear very close to the x-axis. So that's why. But it's always this number right here. Okay. All right. Let's go do another. So 2x squared minus x squared. So clear here. 2x squared minus x plus 2. I think that's it, right? Nope. 2x minus x squared minus 2. My bad. Just hit clear. 2x minus x squared plus 2. Now, normally you would put the quadratic term first, right? You'd said, oh, okay, that's negative x squared plus 2x. Shoot. Minus 2, and I better go check and see if that's, yeah, I didn't, did I? Put a minus there. All right. So that's, you can type it in like this, that's fine, but normally it would be in this form, the quadratic term, the linear term because it has a power of 1, quadratic term because it has power of 2, and here's your constant, right? So actually 3 parts to your quadratic in standard form. So we're going to find the x-intercepts and the vertex, and then we already know what this is, 0, negative 2, right? It's that one right there. It's the constant. Okay. Now, here's a really cool thing. If your quadratic does not have a constant, then that would mean that your x-intercept, not your x-intercept, your y-intercept would be 0 because you would be plus 0 and it wouldn't change anything. Okay. Now let's go graph this and graph. Note that I need to change my limits. So zoom 6. All right, so this is fine. Well, except for this. Does it touch the x-axis? And it doesn't. So what we have to do is, for the x-intercepts, DNE. If it doesn't cross the x-axis, you can't have x-intercepts. So if it doesn't cross the x-axis, like we're seeing here, then we know what we have, the roots. In an algebra class, we would say that those are imaginary roots, meaning you would have a negative underneath the square root in the quadratic formula. Okay, when you take the square root of a negative number, it's imaginary, and that's what this particular equation would give you. So just be mindful of that. Now, we do need the vertex. Now, you can find the vertex whether it crosses x-axis or not. Those two different entities there, okay? So let's go second trace, and it's a maximum because it's opening down, right? So that's a good spot right there for my left bound. Now let's go up and over. That's a good spot on my right, and then hit enter, and it's at 1, negative 1. Make sure that you have these as points and not just single coordinates, okay? Now, okay. Now we're going to do a couple more, and they just want the x-intercepts. X-intercepts are really the zeros, right? zeros. And note that they want things in points, right? Separate points with a comma, okay? So they want us to do vertex and then the zeros. So we'll do the first one, and then you should be good enough to do that. Yeah. Okay. All right. So 4x squared. So let's go 4x minus x squared. Yeah. 4x minus x squared. Okay. Hit graph. Make sure that I got this correct. 4x minus x squared. Yeah. All right. So I want you to see something real quick. It doesn't have a constant. It doesn't have a plus some number. So we would know that the y-intercept is 0, right? Well, that's cool because when you go to graph this, if the y-intercept is 0, guys, one of your zeros or your x-intercepts would be 0. It's got to, right? I mean, if it's crossing the y-axis at 0, it's also crossing the x-axis at 0. Seeing as that point is the origin where the two axes are joined on the coordinate plane. So we're good there. Okay, x-intercept separated by commas. Now, they stay in points, so I'm putting them as ordered pairs. Let's go find the other one. It should be out here, so maybe 1, 2, 3, 4, maybe 4. Let's go see. Second trace, I want a 0. Again, I'm going to create a left bound, right? And basically, folks, what that left bound and right bound is doing is just, like I said, encasing, having the calculator only look between these 2 points for a certain condition. And that's what it's giving you back. So it is at 4, 0. You could have went to second table, and you could have went to your table. So you have an output at 0 of a y value of 0. And if you look down here at 4, its output is at 0. And that would mean when your y value is 0, you have an x-intercept or a 0 or a solution, right? So you could have done it with a table too. But not all of them cross perfectly at a grid mark. So, but you could have on this one went and double checked that. Now, what else they want? They want the vertex, right? So let's go do this. Second trace vertex. So it's opening down, so I need a maximum. So I got to go back up. All right, there. And by now, if you have used your calculator accordingly and done these steps, these things ought to be very easy and done quickly and efficiently. The maximum of the vertex is 2, 4. And there you go. Now, yeah, this concludes 6.3's video. I'm not going to do the last one because it's basically just like what I just done. So part 2's videos, chapter 4, section 6.3, part 2.